Hello everyone, this is Teacher Regil. This lesson will address the competency determine the equation of a quadratic function given its roots. First, we are going to review how to find the zeros of a quadratic function. I have here find the zeros of y equals x squared plus 5x minus 14. Now, we can equate first our quadratic function. We will make it a quadratic equation, x squared plus 5x minus 14 equals 0. Now, we factor because this quadratic equation can be factored. So the factors of x squared plus 5x minus 14 are x plus 7 and x minus 2. After we get the factors, we are going to equate both factors to 0. So the first factor is x plus 7 equals 0. Second factor, x minus 2 equals 0. Then after that, we are going to solve each equation separately. For our first equation, if we subtract 7 from both sides, we get x equals negative 7. For our second equation, if we add 2 on both sides, we have x equals 2. Now, the two zeros are negative 7 and 2. We will let the negative 7 to be our first 0, x sub 1, and 2 be our second 0, x sub 2. If we are going to multiply these two zeros, negative 7 and 2, we will get negative 14. Now notice here that this negative 14 is actually equal to this last term of our quadratic function. And also, if we are going to add the two zeros, negative 7 and 2, it is equal to negative 5, which is the opposite of the coefficient of our linear term. So we have an observation that in a quadratic equation in standard form, ax squared plus bx plus c equals 0, the product of the two zeros, x sub 1 and x sub 2, okay, is just actually equal to c, the last term. And also, the sum of the two zeros, x sub 1 and x sub 2, is just actually equal to the opposite of the coefficient of our linear term. Let's do another example. This time, we have a quadratic function with a leading coefficient other than 1. Here it's 2. Now again, we will form our quadratic equation, 2x squared minus 5x minus 3 equals 0. Then we factor. So the factors of 2x squared minus 5x minus 3 are the binomials x, 2x plus 1 and x minus 3. Then we will equate both factors to 0. The first factor, 2x plus 1 equals 0. And the second factor, x minus 3 equals 0. Then we will solve the two equations separately. So 2x plus 1, if we subtract 1 from both sides, we have 2x equals negative 1. Divide both sides by 2, so x equals negative 1/2. And for our second equation, if we add 3 on both sides, x equals 3. And now, the two roots or the two zeros are negative 1/2 and 3. We will let negative 1/2 be our first 0, x sub 1, and 3 be our second 0, x sub 2. If we are going to multiply these two zeros, negative 1/2 and 3, we will have a product of negative 3 over 2. And comparing this negative 3 over 2 to our quadratic function is just actually the last term here, negative 3, over the leading coefficient. And also, if we are going to add the two zeros, negative 1/2 and 3, the sum is 5 over 2. This 5 over 2, okay, if we observe, is just actually the opposite of the coefficient of the linear term over the leading coefficient. So, in a quadratic equation written in standard form, ax squared plus bx plus c equals 0, the product of the two zeros x sub 1 and x sub 2 is just actually equal to c over a. Okay? The last term here over the leading coefficient. And also, the sum of the two zeros is actually equal to the opposite of the coefficient of the linear term over the leading coefficient. So it's negative b over a. So we will use this idea in finding the equation of our quadratic function given the zeros. Let's do example number 1. Determine the equation of the quadratic function in the form y equals ax squared plus bx plus c, whose zeros are 5 and 6. Now notice here again that the last term is just actually the product of the two roots. So 5 times 6 is 30. So this is c, 30. And also the b, the value of b, is just actually the opposite of the sum of the two zeros, 5 plus 6. So it's 11. The opposite is negative 11. So therefore, our quadratic equation is x squared minus 11x plus 30 equals 0. Now for our quadratic function, we will just replace this equals 0 with y. So the quadratic function is y equals x squared minus 11x plus 30. Let's do another example. Determine the equation of the quadratic function y in the form y equals ax squared plus bx plus c, whose zeros are 2/3 and negative 5. Now, first, because we have here fractions from the observation we have, okay, we know that when we multiply the two zeros, it is actually equal to c over a. So 2 over 3 times negative 5 is negative 10 over 3. And also, to find b, or if we are going to add the two zeros, it's actually equal to the opposite of the sum, okay, of the two zeros. So the b over a is actually the opposite of the sum, 2/3 plus a negative 5, okay, that's actually negative 13 over 3, because it's the opposite, it's 13 over 3. Now, we can now write our quadratic equation. So x squared plus 13 over 3x minus 10 over 3. Now we can get rid of the denominator 3 by multiplying all terms by 3. So if you multiply all terms by 3, we have 3x squared. And then we multiply it to the second term, so 3 cancels out. So we have 13x. And also if we multiply this to the third term, 3 cancels out, so we have minus 10. So this is the quadratic equation. Now, the quadratic function, we will just replace this equals 0 with y. So y equals 3x squared plus 13x minus 10. I prepared here 3 items for you to work on. So give the equation of the quadratic function y equals ax squared plus bx plus c given the zeros. You can pause the video and work on these items. If you are ready, I can now show you the answer. For item number 1, our quadratic function is y equals x squared minus 11x plus 30. Second, our equation is, our quadratic function is y equals x squared plus 2x minus 63. For item number 3, our quadratic function is 25x squared minus 10x minus 3. Did you get all the items right? I hope you did. Thanks for watching, guys. This is Teacher Regiel. Keep safe.